Okay, today in class we talked about translation. Translation is the process that we use to make amino acids from the mRNA on the ribosome. As we look at translation, we need to use our groups of codons. Codons are 3 nucleotides put together, groups of 3, that code for a specific amino acid. So this is our mRNA sequence that we have, and this is from problem number 4. So if you turn the packet to the second page, looking at problem number 4, it gives us a DNA strand that we transcribed into this RNA strand. AUG, GAA, GCC, UAC, CAG, and UGA. Now we're going to use this mRNA to look up the codons in this chart and determine which codons will code for the amino acids. So we have AUG. In order to read the chart, the A is in the first position, and that is found here on the left side of the chart. A is in this third row, so we're going to stay in the third row for AUG. The second codon, the second nucleotide in the codon is a U, and the second base is red on the top of the chart here, and U is in the first column. So we're going to stay in the third row, work in the first column. We need to find a G now. AUG is MET. So the amino acid that will be coded for with AUG codon is MET. The next codon in the sequence is GAA. Again, the first letter being a G, so the first letter is G, that's the bottom row here. The second letter is an A, the second letter is on the top part of the chart, so A is all the way over here on the third column. So we're in the bottom row, third column. We're going to stay in this box down here at the bottom. And we're looking for GAA, which is found right here, and that codes for the amino acid blue, GLU, and these are abbreviations for the amino acid. As we finish out the codons and filling in the appropriate amino acids, we will see what the remainder of the strand looks like. So give me a moment to do that. We've used the chart now to look up the remaining codons and find the amino acids that would be made from those codons. This is what the tRNA, the mRNA, and the ribosome will do when it builds proteins using amino acids. Looking at the third page of the packet, it gives us another view of translation. Again, translation uses the mRNA that we created during transcription. It also uses this tRNA molecule. The tRNA is holding on to an amino acid, and notice that each of these tRNA molecules is holding on to a different amino acid. The tRNA will pair up with the mRNA based on these codons. So we have the codon AUG on the mRNA. That pairs up with UAC on the tRNA, and UAC tells us the specific amino acid that we're using. Then UUG will tell us to code for a different amino acid. So a different tRNA will attach to UUG than the tRNA that attached to AUG. There are 3 steps to translation. The first step is initiation, where we're bringing the tRNA and the mRNA together inside of this ribosome. During elongation, notice we have 2 tRNA molecules in the ribosome, each holding on to their own amino acid, and we're actually connecting those amino acids together with a bond, a peptide bond. And we call this long strand of amino acids a polypeptide. The third and final step that we have is termination, and when we reach a stop codon, the various pieces that came together in initiation are now released in termination. So we see the tRNA molecules up here are no longer attached. The amino acid chain, the polypeptide, is no longer attached to the tRNA. All the pieces have separated, and they can be used again to make new proteins in the future.